Trigonometric ratios. We're going to begin with right angle triangles. So there's the right angle. If we label one of the other angles theta, doesn't matter which one, we get the longest side as being the hypotenuse, the side next to the angle next to theta being adjacent, and the side all the way on the other end being opposite. My trig ratios are defined as sine theta being opposite over hypotenuse, so opposite over hypotenuse, cosine theta being adjacent over hypotenuse, so adjacent divided by hypotenuse, and the tangent of theta is equal to opposite over adjacent, so opposite divided by adjacent. The acronym to assist you in remembering these trig ratios is SOHCAHTOA. SOH for sine theta equals opposite over hypotenuse, CAH for cosine theta equals adjacent over hypotenuse, and TOA for tangent of theta equals opposite over adjacent. The reciprocal ratios are cosecant, secant, and cotangent, and they are just 1 over the original ratios. That's the reciprocal. The reciprocal is, for a fraction, is just the fraction flipped upside down. So I can also write the cosecant as hypotenuse over opposite, which is just the original sine function upside down. Similarly, secant can be written as hypotenuse over adjacent, which is just the original cosine function flipped upside down. And cotangent can be written as adjacent over opposite, which is just the original tangent function flipped upside down. The first type of question you'll be given all three sides. To find the trig ratios, the first thing that I do is write down the hypotenuse, the adjacent side, and the opposite side. So the hypotenuse is always the longest side. If the triangle is a little bit tricky, then you just find the right angle and you look for whichever side is opposite it. So here's my angle. The only other side that's touching my angle must be adjacent, and all the way on the other side is the remaining opposite. Sine is defined as opposite over hypotenuse, so it's simply 20 over 29. 20 being O, 29 being H. Similarly, cosine is A over H, so 21 over 29. Tangent is O over A, so 20 over 21. Cosecant, H over O, 29 over 20. Secant, H over A, that's 29 over 21. Cotangent, A over O, so 21 over 20. If there is a side unknown, we still label H, A, and O like normal. H, A, O. And then we go about finding the unknown side. So because it's a right angle triangle, we can use Pythagoras' theorem. So finding the hypotenuse, it's a surd. That's okay. We're going to leave it as a surd for the exact ratio. Okay. So sine is O over H, simply 8 being O, root 145 being H. Cos A over H, 9 over root 45. And similarly, all the other functions follow just like previously. If you are given a ratio but not a triangle, and then told to find other ratios, you begin by drawing a triangle and putting your theta in the triangle, then identifying your H, A, and O again. Once you've done that, use the original ratio. In this case, it's tan. Tan is O over A. So 8, being the numerator, must be O. And 15, being the denominator, must be A. Once you've done that, you can use Pythagoras' theorem to figure out the unknown side. In this case, it's 17. Once you've got your three sides, you can figure out all the other ratios simply by using the same system that was used previously. So sine O over H, cosine A over H, and the others very similarly. Thank you.